students of ExamsNet, welcome to the question series of ExamsNet. I hope this series of detailed explanation is helping you a lot. Let's start this session. Let A is equal to Z belongs to C such that modulus of Z minus 1 plus I lies between 1 and 2. And B is equal to Z belongs to A such that modulus of Z minus 1 minus I is equal to 1. Then B is equal to. For this given question, let Z is equal to X plus IY. So, on substituting the value for the given expression for A, we get modulus of X plus IY minus 1 minus I lies between 1 and 2. So, it can be written as X minus 1 plus I, Y minus 1 lies between 1 and 2. So, it can be written as under root of X minus 1 whole square plus Y minus 1 whole square also lies between 1 and 2. It represents two concentric circles, both having center at 1, 1 and radius 1 and 2. It is also given that modulus of Z minus 1 minus I is equal to 1. So here also substituting the value for Z, it becomes modulus of X plus IY minus 1 plus I is equal to 1. Or it can be written as modulus of X minus 1 plus I Y plus 1 is equal to 1. Therefore, under root of X minus 1 whole square plus Y minus 1 whole square will be equal to 1. This represents a circle with center at 1, minus 1 and radius is equal to 1. Therefore, we can say that B will be an infinite set. So, the correct option here is option number D, which is an infinite set. Next question is the remainder when 3 power 2022 is divided by 5 is. See, this can be written as 3 square whole power 1011. So it will be 9 power 1011. 9 can be written as 10 minus 1 power 1011. So this will be equals to 1011 C0 into 10 power 1011 plus so on up to 1011 C1010 into 10 power 1 minus 1011 C1011. So it will be equals to taking 10 common 1011 C0 into 10 power 1010 plus so on up to 1011 C1010 minus 1. So further it can be written as 10k minus 1 because we know that this part is a multiple of 10. So it will be equal to 10k minus 1. Now adding and subtracting 5, this becomes 10k minus 5 plus 5 minus 1. Taking 5 common, it will be 2k minus 1 plus 4. Here we can see that the unit digit is equals to 4 when it is divided by 5. So we can say that the correct answer for this question is option number D, which is 4 here. Next question is the surface area of a balloon of spherical shape being inflated increases at a constant rate. If initially the radius of balloon is 3 units and after 5 seconds it becomes 7 units, then its radius after 9 seconds is. This is a very, very important question. This kind of question always appear in the exam. So here we know that surface area of balloon, which is a sphere, is equal to 4 pi r square. Therefore, ds upon dt will be equal to d by dt of 4 pi r square. So ds upon dt will be equal to 4 pi into 2r into dr upon dt. Therefore, ds upon dt will be equals to 8 pi r into dr upon dt. It is given that surface area of balloon is increasing at a constant rate. So we can say that ds upon dt will be equal to a constant, let us say k. Therefore, k will be equals to 8 pi r into dr upon dt. So, k dt will be equals to 8 pi r dr. On integrating both the sides, it will be equals to kt is equal to 8 pi into r square upon 2 plus c. Or it can be also written as kt is equal to 4 pi r square plus c. Let this be equation number 1. It is given that at t is equal to 0, radius r is equal to 3. So putting this value, we get 0 is equal to 4 pi into 3 square plus c. So c will be equals to minus 36 pi. It is also given that at t is equal to 5, radius r will be equal to 7. So again, substituting the values, we get k into 5 is equal to 4 pi 7 square minus 36. So k will be equal to 32 pi. In this case, the equation 1 becomes 32 pi t is equal to 4 pi r square minus 36 pi. We know that c is 36 pi. So in this case, the equation becomes kt is equal to 4 pi r square minus of 36 pi. Now, at t is equal to 9, the value becomes 32 pi into 9 is equal to 4 pi r square minus 36 pi. So it will be 8 into 9 is equal to r square minus 9. Therefore, r square will be equal to 81 and r will be equal to 9. Hence, we can say that the correct option for this question is option number A here, which is 9. Moving on to the next question. Bag A contains 2 white, 1 black and 3 red balls. And bag B contains 3 black, 2 red and n white balls. One bag is chosen at random and 2 balls drawn from it at random are found to be 1 red and 1 black. If the probability that both balls come from bag A is 6 by 11, then n is equal to. It is given that bag A contains 2 white, 1 black and 3 red balls, and bag B contains 3 black, 2 red and n white balls. Therefore, probability of 1 red and 1 black ball will be equal to P of A into P of 1 red and 1 black upon A plus P of B into P of 1 red and 1 black upon B. So it will be equals to 1 by 2 into 3C1 into 1C1 divided by 6C2 plus 1 by 2 into 2C1 into 3C1 divided by n plus 5 C2. Therefore, we can say that probability of 1 red and 1 black ball divided by A will be equal to 1 by 2 into 3 by 15 whole divided by 1 by 2 into 3 by 15 plus 1 by 2 into 6 into 2 whole divided by n plus 5 and n plus 4. It is equal to 6 by 11, which is already given in the question. On further simplifying, this will be equals to 1 by 10 divided by 1 by 10 plus 6 upon n plus 5 into n plus 4 is equal to 6 by 11. So 11 by 10 will be equals to 6 by 10 plus 36 upon n plus 5 into n plus 4. So we can write it as 5 upon 10 into 36 is equals to 1 upon n plus 5 into n plus 4. On further cross multiplying, it will become n square plus 9n minus 52 is equal to 0. So here n will be equal to 4 and this is only possible value for n. So we can say that the correct answer here is option number C, which is 4. The possible value of n is 4. Next question is, let x square plus y square plus ax plus by plus c is equal to 0 be a circle passing through 0, 6 and touching the parabola y is equal to x square at 2 comma 4. Then a plus c is equal to. We know that for tangent to the parabola, y is equal to x square at point 2 comma 4, dy by dx at 2 comma 4 will be equals to 4. Therefore, the equation of tangent is y minus 4 is equal to 4 into x minus 2. So it will be 4x minus y minus 4 is equal to 0. Now the family of circle is given by x minus 2 whole square plus y minus 4 whole square plus lambda into 4x minus y minus 4 is equal to 0. As it is given in question that it passes through the point 0 comma 6. It means that it should satisfy the points. So it becomes 2 square plus 2 square plus lambda into minus 10 is equal to 0. So lambda will be equals to 4 upon 5. Now, since lambda is equal to 4 upon 5, equation of circle will be x minus 2 whole square plus y minus 4 whole square plus 4 by 5 into 4x minus y minus 4 is equal to 0. So further it can be written as x square plus y square minus 4x minus 8y plus 20 plus 16 by 5x minus 4 by 5y minus 16 by 5 is equal to 0. So here a is equal to minus 4 plus 16 upon 5 and c is equal to 20 minus 16 upon 5. Therefore, a plus c will be equals to 16. Hence, we can say that the value for a plus c is 16. So, the correct option here is option number A, which is 16. I hope this question is clear to you. Next question is the number of values of alpha for which the system of equations are x plus y plus z is equal to alpha, alpha x plus 2 alpha y plus 3z is equal to minus 1, x plus 3 alpha y plus 5z is equal to 4 is inconsistent is. So from the given equation, we can form a determinant and let it be equal to delta. The values will be 1, 1, 1, alpha, 2 alpha and 3, 1, 3 alpha and 5. On further expanding this, it will be 1 into 10 alpha minus 9 alpha minus 1 into 5 alpha minus 3 plus 1 into 3 alpha square minus 2 alpha. So it will be equals to alpha minus 5 alpha plus 3 alpha square minus 2 alpha. On further calculations, this will be equal to 3 alpha square minus 6 alpha plus 3. Now, for inconsistency, delta should be equal to 0. That is, alpha will be equals to 1. Now, let us check for alpha is equal to 1. So, x plus y plus z will be equal to 1. Let this be equation number 1. And x plus 2y plus 3z will be equal to minus 1. Let this be equation number 2. Now, by multiplying 2 in equation number 2 and subtracting equation 1, we get x plus 3y plus 5z is equal to minus of 3. So, we can say that the equations are inconsistent for alpha is equal to 1. Therefore, the correct option here is option number B, which is 1. Next question is, if the sum of the squares of the reciprocals of the roots alpha and beta of the equation 3x square plus lambda x minus 1 is equal to 0 is 15, then 6 into alpha cube plus beta cube whole square is equal to. In this question, two roots are given, which is alpha and beta. Therefore, sum of roots alpha plus beta will be equals to minus lambda upon 3, which is minus b upon a. And product of roots alpha into beta will be equal to minus 1 upon 3. It is given that sum of square of reciprocal of roots alpha and beta is 15. Therefore, 1 upon alpha square plus 1 upon beta square is equal to 15. It is already given in the question. On further solving it, it becomes alpha square plus beta square divided by alpha into beta whole square So it will be equal to 15. Now this can be written as alpha plus beta whole square minus 2 alpha beta divided by alpha into beta whole square is equal to 15. On putting the value for alpha plus beta and alpha into beta, it becomes lambda square upon 9 plus 2 into 1 by 3 divided by 1 by 9 is equal to 15. Therefore, lambda square plus 6 divided by 9 upon 1 by 9 is equal to 15. So lambda square plus 6 will be equals to 15. Lambda square will be 9. Now we have to find the value for 6 into alpha cube plus beta cube whole square. It can be written as 6 into alpha plus beta into alpha square plus beta square minus alpha beta whole square. So 6 into alpha plus beta whole square multiplied by alpha plus beta whole square minus 2 alpha beta minus alpha beta whole square. So it will be equals to 6 into minus lambda upon 3 whole square into minus lambda upon 3 whole square minus 3 into minus 1 by 3 whole square. So it will be equals to 6 into lambda square upon 9 into lambda square upon 9 plus 1. On further solving this, it becomes 6 into 9 upon 9 because we know that lambda square is equal to 9 into again 9 upon 9 plus 1 whole square. So this will be equals to 6 into 2 square, which is 6 into 4, which is equal to 24. Hence, we can say that the correct answer for this question is 24. Therefore, the correct option is option number B here. Next question is the set of all values of k for which tan inverse x cube plus cot inverse x cube minus k pi cube where x belongs to Ru is the interval. We have to find the interval for all the values of k here. The given expression can be written as tan inverse x cube plus cot inverse x cube is equals to k pi cube. Let f of t is equals to t cube plus pi by 2 minus t cube, where t is equals to tan inverse x and x belongs to minus pi by 2 and plus pi by 2. Therefore, it will be equals to t cube plus pi by 2 cube minus 3 pi square t divided by 4 plus 3 pi t square divided by 2 minus t cube. So f of t will be equals to 3 pi t square divided by 2 minus 3 pi square t divided by 4 plus pi cube upon 8. It is clear that this is a quadratic equation of t, and here the coefficient of t square is 3 pi by 2. It is greater than 0. Therefore, we can say that it is an upward parabola, and f dash t will be equals to 3 pi t minus 3 pi square divided by 4. F double dash t will be equals to 3 pi greater than 0. Therefore, 3 pi t minus 3 pi square by 4 is equal to 0. So t will be equals to pi by 4, which is the minimum value, and the vertex of the graph of the parabola will be at pi by 4. So the graph will be in this way. This will be minus pi by 2. This will be plus pi by 2. And this is pi by 4. Therefore, the maximum value is at minus pi by 2 and the minimum value is at pi by 4. So, f of pi by 4 will be equals to pi cube upon 64 plus pi by 2 minus pi by 4 whole cube which is equal to pi cube upon 32. And f of minus pi by 2 will be equal to minus pi cube upon 8 plus pi cube. So this will be equals to 7 pi cube upon 8. Hence we can say that k pi cube belongs to pi cube upon 32 and 7 pi cube upon 8. So k belongs to 1 upon 32 and 7 upon 8. Hence, the correct option for this question is 1 upon 32 and 7 upon 8. So the correct option is option number A here. Moving on to next question, let S is equal to root n such that n lies between 1 and 50 and n is odd. Let A belongs to S and matrix A is equals to 1 0 A minus 1 1 0 minus A 0 1. If summation of A belongs to S, determinant of adjoint of A is equal to 100 lambda, then lambda is equal to. So we have to find the value for lambda here. The given matrix is 3 cross 3 matrix and a set is given which is S, which will consist of the elements 1 under root 3, under root 5, under root 7, so on up to under root 49. We know that determinant of adjoint of A will be equals to determinant of A power n minus 1. Here n is the order of matrix and we have 3 cross 3 matrix. Therefore, n will be equals to 3. Therefore, determinant of adjoint of A will be equal to determinant of A power 3 minus 1, which is equal to determinant of A square. Now let us calculate determinant of A. So determinant of A will be in this way, 1 0 A minus 1 1 0 and minus A 0 1. On further expanding this, it will be equals to 1 into 1 minus 0 plus A into 0 minus minus A. So this will be equals to A square plus 1. Since we know that determinant of adjoint of A is equals to determinant of A square. So it will be A square plus 1 whole square. Now we have to calculate summation of A belongs to S, determinant of adjoint A. So this will be equals to summation of A belongs to S, A square plus 1 whole square. On putting the values here, it will be 1 square plus 1 whole square plus root 3 square plus 1 whole square plus root 5 square plus 1 whole square plus so on up to root 49 square plus 1 whole square. So this will be equals to 1 square plus 1 whole square plus 3 plus 1 whole square plus 5 plus 1 whole square plus so on up to 49 plus 1 whole square. So on adding these values, it will be 2 square plus 4 square plus 6 square plus so on up to 50 square. You can see that the series is consisting of the even numbers. So taking 2 square common, remaining terms will be 1 square plus 2 square plus 3 square plus so on up to 25 square. So this will be equals to 4 into 25 into 26 into 51 divided by 6. On further calculation, this will be equals to 100.221. Or we can say that 100 into 221. It is given that determinant of adjoint of A is equal to 100 lambda. So 100 lambda will be equals to 100 into 221. So lambda will be equals to 221. Hence we can say that the required value for lambda is 221. So the correct option is option number B here. Next question is for the function f of x is equals to 4 log base e x minus 1 minus 2x square plus 4x plus 5 where x is greater than 1. Which one of the following is not correct? The function is given, which is f of x. So first let us find the derivative of the given function. So f dash x will be equals to 4 upon x minus 1 minus 4 into x minus 1. For x lies between 1 and 2, f dash x will be greater than 0. For x is greater than 2, f dash x will be less than 0. So we can say that the first option is correct, which is f is increasing in 1 comma 2 and decreasing in 2 comma infinity. Now f of x is equals to minus 1 has two solutions. So we can say that option B is also correct. Now f of e is greater than 0. If f of e is greater than 0, then f of e plus 1 will be also less than 0. Now f of e into f of e plus 1 will be less than 0. So we can say that option D is also correct. Now f dash e minus f double dash 2 will be equals to 4 upon e minus 1 minus 4 into e minus 1 plus 8 will be greater than 0. So we can say that option C is not correct. You have to remember one thing, that we have to find the option which is not correct here. So A is correct, B is correct, and D is correct. So the option which is not correct is option number C here. So the required option for this question is option number C. Moving on to the next question. If the tangent at the point x1 comma y1 on the curve y minus x cube plus 3x square plus 5 passes through the origin, then x1 y1 does not lie on the curve. So let us understand the curve first. Let this be the tangent for the curve. Let this be a point, and let this be the required curve. This is O, which have the coordinates 0 comma 0, and let this be point P, which is x1 comma y1. The curve is given, and it can be also written as y is equal to x cube plus 3x square plus 5. The curve is given here. Now slope of tangent will be dy by dx is equals to 3x square plus 6x. Now slope of line joined by x1 comma y1 and 0 comma 0 is y0 minus 0 divided by x1 minus 0. Therefore, we can say that y1 upon x1 will be equals to 3x1 square plus 6x1 square. So y1 will be equals to 3x1 cube plus 6x1 square. Let this be equation number 1. We know that point x1 comma y1 is on the line. So y1 will be equals to x1 cube plus 3x1 square plus 5. Let this be equation number 2. Therefore, we can say that 3x1 cube plus 6x1 square is equals to x1 cube plus 3x1 square plus 5. Since in both the equation LHS is equal, so RHS will also be equal. So 2x1 cube plus 3x1 square minus 5 is equal to 0. When x is equal to 1, then the equation is satisfied. Now y1 will be equals to x1 cube plus 3x1 square plus 5. So this will be equals to 1 plus 3 plus 5. So y1 will be equals to 9 and x1 will be equals to 1. When x is equal to 1, then y is equal to 9. But here the coordinates are x1 and y1. So we can say that when x1 is equal to 0, we cannot determine the correct value for y1. But when x1 is equal to 1, y1 will be equals to 9. So option D does not satisfy the point 1 comma 9 here. So we can say that the correct option here is option number D, which is x by 3 minus y square is equal to 2. We can also solve it. X by 3 minus y square is equal to 2. We have x1 as 1. So 1 by 3 minus, we have y as 9. So 81. It cannot be equal to 2. So the option that does not lie on the curve is x by 3 minus y square is equal to 2. Next question is the sum of absolute maximum and absolute minimum values of the function f of x is equals to mod of 2x minus 1 and x plus 2 plus sine 2x upon 2 in the interval 0, 1 is. You can see that the function is 2x square plus 3x minus 2. By splitting the middle term, it can be written as 2x minus 1 into x plus 2. And sine x cos x can be written as sine 2x upon 2. Here, x lies between 0 and 1 by 2. So, f of x can be also written as 1 minus 2x and x plus 2 plus sine 2x upon 2. Now, f dash x will be equals to minus 4x minus 3 plus cos 2x less than 0. Now, when x is greater than or equal to 1 by 2, f dash x will be equal to 4x plus 3 plus cos 2x. It is greater than 0. So, minimum value occurs at x is equal to 1 by 2. So, f of x at minimum value will be equal to mod of 2 into 1 by 2 square plus 3 by 2 minus 2 plus sine 1 by 2 into cos 1 by 2. So this will be equals to 1 by 2 sine 1. Therefore, we can say that maximum value is possible at x is equal to 0 or x is equal to 1. Now, checking for x is equal to 0 and x is equal to 1, we can see that it attains its maximum value at x is equal to 1. So the correct option for maximum value is x is equal to 1 and not x is equal to 0. Now, f of x at maximum will be equal to mod of 2 plus 3 minus 1 plus sine 2 divided by 2. So it will be equals to 3 plus 1 by 2 sine 2. Now we have both minimum and maximum value. So sum of absolute minimum and maximum values will be 3 plus 1 by 2 sine 1 plus sine 2. Hence we can say that this is the required answer and the correct option will be 3 plus 1 by 2 into sine 1 plus sine 2, which can be written as 1 plus 2 cos 1 into sine 1. So the correct option will be option number B here. I hope this question is clear to you. Next question is a very, very interesting question. If I power n, where n is an even integer, is an arithmetic progression with common difference 1 and summation of I is equal to 1 to n, ai is equal to 192 and summation of I is equal to 1 to n up by 2, a to I is equal to 120, then n is equal to. So for this given question, we have to find the value for n. It is given that summation of I is equal to 1 to n, ai is equal to 192. So on putting the values, the series will be a1 plus a2 plus a3 plus so on up to an is equal to 192. So sum will be n by 2 into a1 plus an is equal to 192, or we can say that a1 plus an will be equals to 384 upon n. Let this be equation number 1. Now, one more thing is given in the question, which is summation of I is equal to 1 to n by 2. A to I is equal to 120. So, A2 plus A4 plus A6 plus so on up to an is equal to 120. Here, total n by 2 terms are present. So, the sum will be n by 2 upon 2 into a2 plus an is equal to 120. So, n by 4 into a2 plus an is equal to 120. It can be also written as n by 4 into a1 plus 1 plus an. So we can say that a1 plus 1 plus an is equals to 480 upon n. Let this be equation number 2. We have two equations in the terms of sum of the series. Now subtracting equation 1 from 2, we get 1 is equal to 480 upon 9 minus 384 upon n. We have subtracted equation 1 from 2. So the required term is 1 is equal to 480 upon n minus 384 upon n. So 1 will be equals to 96 upon n. So n will be equals to 96. Hence we can say that the correct option here is option number B, which is 96. Next question is, if x is equal to x of y is the solution of the differential equation y dx upon dy is equals to 2x plus y cube into y plus 1 e power y, where x of 1 is equal to 0, then x of e is equal to. See, the given equation can be also written as dx upon dy minus 2x upon y will be equal to y square into y plus 1 power e power y. Now, if this is equal to e power integral of minus 2 by y dy, so it will be equals to e power minus 2 log y, which will be equals to 1 upon y square. Now, the solution of this equation is given by x into 1 upon y square is equal to integral of y square into y plus 1 into e power y into 1 upon y square dy. So x upon y square will be equals to integral of y plus 1 into e power y dy. So x upon y square will be equals to y into e power y plus c. So x will be equals to y square into y into e power y plus c at y is equal to 1 and x is equal to 0. So we can say that putting the value of x and y, this expression becomes 0 is equal to 1 into e power 1 plus c. So we can say that c will be equals to minus e at y is equal to e. Therefore, x will be equals to e square into e power e minus e. So we can say that the value of x of e will be equals to e cube e power e minus 1. Hence, the correct option for this question is option number A here. Moving on to next question. Let lambda x minus 2y is equal to mu be a tangent to the hyperbola a square x square minus y square is equal to b square. Then lambda upon a square minus mu upon b square is equal to. The given equation for hyperbola, which consists of a tangent, can be also written as x square upon b square upon a square minus y square upon b square is equal to 1. Here, the tangent in the slope form will be equal to y is equal to mx plus minus under root b square a square into m square minus b square. That is same as y is equal to lambda x upon 2 minus mu upon 2. So comparing the coefficient, we can say that m is equal to lambda upon 2, b square upon a square into m square minus b square is equal to mu square upon 4. Now eliminating m, this expression becomes b square upon a square into lambda square upon 4 minus b square is equal to mu square upon 4. So we can say that lambda square upon a square minus mu square upon b square will be equal to 4. Hence the correct answer for this question is 4. So correct option is option number D here. Next question is, let a cap and b cap be unit vectors if c vector be a vector such that an angle between a cap and c vector is pi by 12 and b cap is equal to c vector plus 2 into c vector cross product a cap, then mod of 6c vector whole square is equal to. It is given that b cap is equals to c vector plus 2 into c vector plus a cap. Therefore, b cap dot product c vector will be equal to modulus of c vector whole square. Therefore, b cap minus c vector will be equals to 2 into c vector cross product a vector. So, mod of b cap whole square plus mod of c vector whole square minus 2 into b cap into c vector will be equals to 4 into mod of c vector whole square into mod of a vector whole square into sine square pi by 12. On further solving this, it will be 1 plus mod of c vector whole square minus 2 into mod of c whole square is equal to 4 into mod of c vector whole square into root 3 minus 1 divided by 2 root 2 whole square. So this will be equals to 1 is equal to mod of c vector whole square into 3 minus root 3. So 36 into mod of c vector whole square will be equal to 36 upon 3 minus root 3. So this will be equals to 6 into 3 plus root 3. Hence we can say that the correct option for this question is 6 into 3 plus root 3, which is option number C here. Next question is, if a random variable x follows the binomial distribution b 33, p such that 3p x is equal to 0 is equals to p of x is equal to 1, then the value of p of x is equal to 15 divided by p of x is equal to 18 minus p of x is equal to 16 divided by p of x is equal to 17 is equal to. We know that this expression can be written as 3 into nc0 p power 0 1 minus p power n equal to nc1 p power 1 1 minus p power n minus 1. So 3 upon n is equal to p upon 1 minus p. It will be equals to 1 upon 11, which will be equals to p upon 1 minus p. So 1 minus p will be equals to 11p. So p will be equals to 1 upon 12. Now we have to find p of x is equal to 15 divided by p of x is equal to 18 minus p of x is equal to 16 divided by p of x is equal to 17. So it will be equals to 33c 15 p power 15 into 1 minus p power 18 divided by 33c 18 p power 18 into 1 minus p power 15 minus 33c 16 p power 16 into 1 minus p power 17 divided by 33c 17 p power 17 into 1 minus p whole power 16. So this will be equals to 1 minus p divided by p whole cube minus 1 minus p divided by p. So it will be 11 cube minus 11. So it will be equals to 1320. Hence we can say that the required answer for this question is 1320, which is option number A here. Next question is a very, very interesting question. The domain of the function f of x is equals to cos inverse x square plus 5x plus 6 divided by x square minus 9 whole divided by log base e x square minus 3x plus 2 is. We just have to find the domain. Here, the part x square minus 5x plus 6 divided by x minus 9 lies between minus 1 and plus 1. Also, x square minus 3x plus 2 is greater than 0 and it is not equals to 1. Therefore, we can say that x minus 3 into 2x plus 1 divided by x square minus 9 will be greater than or equal to 0, and 5 into x minus 3 divided by x square minus 9 will be greater than or equal to 0. See, here there is x square, not x. Now, we know that both these values are greater than or equal to 0. So, the solution of this inequality will be x belongs to minus 1 by 2 and infinity minus 3 for x square minus 3x plus 2 greater than 0 and not equals to 1. X belongs to minus infinity comma 1 union 2 comma infinity minus 3 minus root 5 by 2 and 3 plus root 5 by 2. Now, combining the two solution sets, which is taking the intersection, we can say that x belongs to minus 1 by 2 comma 1 union 2 comma infinity 2 3 minus root 5 by 2 and 3 plus root 5 by 2. So we can say that this is the required domain for the given function f of x. Hence, the correct option here is option number D. Next question is, let a set S is equal to theta, where theta belongs to minus pi comma pi minus plus minus pi by 2, such that sine theta into tan theta plus tan theta is equal to sine 2 theta. If t is equal to summation of theta belongs to S cos 2 theta, then t plus n of S is equal to. So a set is given which have sine theta into tan theta plus tan theta is equals to sine 2 theta. This can be written as tan theta sine theta plus 1. On taking tan theta common, this is the remaining term. And minus of sine 2 theta is equal to 0. Now, it can be also written as tan theta into sine theta plus 1 minus 2 cos square theta is equal to 0. Tan theta will be equal to 0, or 2 sine square theta plus sine theta minus 1 will be equal to 0. It implies that 2 sine theta plus 1 into sine theta minus 1 will be equal to 0. So we can say that sine theta will be equals to minus 1 by 2 or 1. But sine theta is equal to 1 is not possible, because theta will be equals to 0, pi, minus pi by 6 and minus 5 pi by 6. So sine theta is equal to 1 is not possible. So here n of S is equal to 5. So t will be equal to summation of cos 2 theta, which will be cos 0 degree plus cos 2 pi plus cos minus 2 pi plus cos minus 5 pi by 3 plus cos minus of pi by 3. So on further adding these values, t will be equals to 4. Hence, we can say that the required answer for this question is 4. But here you can see that in the options, we have asked t plus n of S. T is equal to 4 and n of S is equal to 5. So 4 plus 5 will be equals to 9. Hence, the correct option is option number B here. Next question is the number of choices for delta belongs to intersection union such that P delta Q is P delta belongs to Q union P delta Q is a tautology is. So we have to find the number of choices. Here, this question is a little bit different from all the previous question that we are solving. It is given that it is a tautology. It means that P delta Q union P delta Q becomes P union Q union P union Q, which is always true. So X becomes a tautology. Now, there are several cases. Another case is when delta is same as intersection, then P intersection Q will be equals to P intersection Q union P intersection Q. Now, if P intersection Q is T, then X cannot be a tautology because this term will be F, therefore X cannot be a tautology. Another case is when delta is same as, then we can say that P to Q union again P to Q is same at P union Q whole union P union Q, which is also true. So X becomes a tautology here also. And the last case is for the last symbol, which is P Q such that P Q union P and Q. So here we can say that the conclusion will be P is to Q is true when P and Q have same truth values. Then P will be minus of Q or the symbol which is represented by Q, and this will be the another condition. Both this condition will be false. Hence we can say that X cannot be a tautology. So for two possible cases or choices, X is a tautology. So we can say that the correct option here is option number B, which is 2. Next question is the number of 1-1 functions, and the function is f such that a, b, c, d consist of 0, 1, 2, so on up to 10, such that 2 f of a minus f of b plus 3 f of c plus f of d will be equal to 0 is. See, this expression can be written as 3f of c plus 2f of a plus f of d is equals to f of b. Now, case 1 will be, let f of c is equal to 0 and let f of a is equal to 1. Then 3 into 0 plus 2 into 1 plus f of d will be equal to f of b, or we can say that 2 plus f of d is equal to f of b. Now, the possible values of f of d will be 2, 3, 4, 5, 6, 7 and 8. We know that f of d can't be 9 and 10, as if f of d is equal to 9 or 10, then f of b will be equals to 2 plus 9, which is 11, or f of b will be equals to 2 plus 10, which is 12, which is not possible here, as any function is maximum value can be 10. Therefore, we can say that the total possible functions when f of c is equal to 0 and f of a is equal to 1 are 7. There are total possible 7 functions in this case. Now, another case is when f of c is equal to 0 and f of a is equal to 2. Then 3 into 0 plus 2 into 2 plus f of d will be equals to f of b. So 4 plus f of d will be equals to f of b. Therefore, possible values of f of d will be 1, 3, 4, 5 and 6. So we can say that total possible functions will be 5. Now the third case is when f of c is equal to 0 and f of a is equal to 3. In this case, 3 into 0 plus 2 into 3 plus f of d will be equal to f of b, or we can say that 6 plus f of d will be equals to f of b. Therefore, possible values of f of d, we are writing possible values for f of d when f of c is equal to 0 and f of a is equal to 3, 1, 2 and 4. So possible functions here in this case will be 3. Again, considering another case is when f of c is equal to 0 and f of a is equal to 4, then we can say that 8 plus f of d is equal to f of b. So, possible values of f of d will be equals to 1, 2. So, total possible functions are 2 here. Similarly, when f of c is equal to 0 and f of a is equal to 5, we can say that 10 plus f of d is equal to f of b. But the possible value of f of d cannot be 0. But f of c is already 0. So no value to f of d can satisfy. Therefore, no function is possible in this case. Now, the total functions in this case regarding all the conditions are 7 plus 5 plus 3 plus 2, which is equal to 17. Now, talking about the second case is when f of c is equal to 1 and f of a is equal to 0. So, the function becomes 3 into 1 plus 2 into 0 plus f of d is equals to f of b. So, it will be 3 plus f of d is equal to f of b. Possible values are 2, 3, 4, 5, 6 and 7. So, total number of functions are 6. Similarly, another condition will be when f of c is equal to 1 and f of a is equal to 2. In this case, we can say that 7 plus f of d will be equal to f of b. So possible values here for f of d will be 0, 3. So total functions are again 2. Similarly, next condition will be when f of c is equal to 1 and when f of a is equal to 3. In this case, we have 9 plus f of d is equal to f of b. So possible values for f of d will be equal to 0. So total possible function is 1 in this case. So regarding case 2, the total functions in all the conditions are 6 plus 2 plus 1, which is equal to 9. Now, again talking about case third. See, we have already seen case 1 and case 2. Now looking forward to case third, when f of c will be equal to 2 and f of a will be equal to 0, then we can say that 6 plus f of d will be equal to f of b. The possible values here are 1, 3 and 4. So possible functions are 3. Similarly, when f of c is equal to 2 and f of a is equal to 1, then 8 plus f of d is equal to f of b. So possible values for this condition is 0 and function will be 1. Therefore, we can say that the total possible functions regarding these two conditions will be 3 plus 1, which is 4. Now talking about the last case, which is case fourth. The case here is when f of c is equal to 3 and f of a is equal to 0. In this case, we have 9 plus f of d is equal to f of b. So the possible values for f of d will be 1. Therefore, the total 1 functions from these 4 cases will be equals to 17 plus 9 plus 4 plus 1. So on adding all these values, we get 31. Hence, we can say that the correct option for this question is 31. And we can write the answer as 31 here. So the answer will be 31. Next question is, in an examination, there are 5 multiple choice questions with 3 choices, out of which exactly 1 is correct. There are 3 marks for each correct answer, -2 marks for each wrong answer, and 0 mark if the question is not attempted. Then the number of ways a student appearing in the examination gets 5 marks is. So let student marks X correct answer and Y incorrect answers. So we can say that 3x minus 2y will be equals to 5. X plus y will be less than or equals to 5, where both x and y belongs to W. Only possible solution is x comma y, which is 3 comma 2. Here, student can mark correct answers by only one choice, but for an incorrect answer, there are 2 choices. Therefore, the total number of ways of scoring 5 marks will be equals to 5c3, 1 power 3 into 2 power 2. So it will be equals to 40. Hence, we can say that the required answer for this question is 40. Next question is, let A 3 upon root A comma under root A, where A is greater than 0, be a fixed point in the xy plane. The image of A in y-axis be B and the image of B in x-axis be C. If D 3 cos theta comma A sin theta is a point in the 4th quadrant such that the maximum area of triangle ACD is 12 square units, then A is equal to. So we just have to calculate the value for A here. It is clear from the question that B will be minus 3 upon under root A and plus under root A, and C will be minus 3 upon under root A and minus of under root A. So area of triangle ACD will be equals to half into determinant of 3 upon under root A 1 minus 3 upon under root A minus of under root A 1, 3 cos theta A sin theta and 1. So delta will be equals to 0, 0, 0 minus 3 upon under root A minus under root A 1 and 3 cos theta A sin theta and 1. So we can say that on expanding this value, it will be equals to modulus of 3 root A sin theta plus 3 root A cos theta. So it will be equals to 3 root A modulus of sin theta plus cos theta. So delta max or delta maximum will be 3 root A into root 2, which is equal to 12. So we can say that A will be equals to 2 root 2 whole square, which will be equals to 8. Hence, we can say that the value of A is 8. So the correct answer for this question is 8. Next question is a very, very interesting question. Let a line having direction ratios 1, -4, 2 intersects the line x minus 7 upon 3 is equal to y minus 1 upon -1 is equal to z plus 2 upon 1 and x by 2 is equal to y minus 7 upon 3 is equal to z upon 1 at the points A and B. Then AB square is equal to, we have to find AB square. Let A 3 lambda plus 7 minus lambda plus 1 and lambda minus 2 and B 2 mu comma 3 mu plus 7 comma mu. So the direction ratios of AB proportional to 3 lambda minus 2 mu plus 7 minus lambda plus 3 mu plus 6 and lambda minus mu minus 2 clearly will be 3 lambda minus 2 mu plus 7 divided by 1 is equal to lambda plus 3 mu plus 6 divided by 4 is equal to lambda minus mu minus 2 divided by 2. Therefore, 5 lambda minus 3 mu will be equal to 16 and lambda minus 5 mu will be equals to 10. Now, from both this equation, we get the value of lambda which will be equals to minus 5 and mu will be equals to minus 3. So we can say that A is minus 8 comma 6 comma minus 7 and B is minus 6 comma minus 2 comma minus 3. Therefore, AB will be equals to under root of 4 plus 64 plus 16. So it will be equals to under root of 84. So AB square will be equals to 84. Hence, we can say that the value for AB square is 84. So the correct answer here is 84. I hope this question is clear to you. Moving on to the next question. The number of points where the function f of x is equal to mod of 2x square minus 3x minus 7 if x is less than equals to minus 1. F of x is equal to 4x square minus 1 if x lies between minus 1 and plus 1. And f of x is equal to mod of x plus 1 plus mod of x minus 2 if x is greater than or equal to 1. If t denotes the greatest integer less than equal to t is discontinuous is. Here, a function is given and 3 different conditions are given. Since we know that f of minus 1 will be equals to 2 and f of 1 will be equals to 3 for x belongs to minus 1 comma 1 and 4x square minus 1 belongs to minus 1 comma 3. Hence we can say that f of x will be discontinuous at x is equal to 1 and also when 4x square minus 1 is equal to 0, 1 or 2, then x will be equals to plus minus 1 by 2, plus minus 1 upon root 2 and plus minus root 3 by 2. So we can say that there are total 7 points of discontinuity. So the correct answer here is 7. Next question is f of theta is equal to sine theta plus minus pi by 2 to plus pi by 2 sine theta plus t cos theta into f of t dt. Then the value of mod of integral of 0 to pi by 2 f of theta d theta is. So we have to find the value of this expression. F of theta can be written as sine theta into 1 plus integral of minus pi by 2 to plus pi by 2 f of t dt plus cos theta integral of minus pi by 2 to plus pi by 2 t f of t dt. Clearly, f of theta will be equals to a sine theta plus b cos theta, where a is equal to 1 plus integral of minus pi by 2 to plus pi by 2 a sine t plus b cos t dt. So a will be equals to 1 plus 2b. Let this be equation number 1. And b is equal equal to integral of minus pi by 2 to plus pi by 2 at sin t plus bt cos t dt. Therefore, we can say that b is equal to 2a. Let this be equation number 2. From both the equation 1 and 2, a will be equals to minus 1 by 3 and b will be equals to minus 2 by 3. So f of theta will be equals to minus of 1 by 3 into sin theta plus 2 cos theta, which will be equals to modulus of integral of 0 to pi by 2 f of theta d theta. So 1 by 3 into 1 plus 2 into 1. So it will be equals to 1. Hence, we can say that the required answer for this question is 1. Next question is a very interesting question. Let maximum value when x lies between 0 to 2, 9 minus x square divided by 5 minus x is equal to alpha, and minimum value when x belongs to 0 and 2, 9 minus x square divided by 5 minus x is equal to beta if integral of beta minus 8 by 3 to 2 alpha minus 1 maximum of 9 minus x square upon 5 minus x comma x dx is equal to alpha 1 plus alpha 2 log base e 8 upon 15, then alpha 1 plus alpha 2 is equal to. So we have to find the value for alpha 1 and alpha 2. Let f of x is equals to x square minus 9 divided by x minus 5. So f dash x will be equals to x minus 1 into x minus 9 divided by x minus 5 whole square. So alpha will be equals to f of 1, which is equal to 2, and beta will be equals to minimum of f of 0 and f of 2, which will be equals to 5 by 3. Now, integral of minus 1 to 3 maximum of x square minus 9 divided by x minus 5 comma x dx will be equals to integral of minus 1 to 9 by 5 x square minus 9 divided by x minus 5 dx plus integral of 9 by 5 to 3 x dx will be equals to integral of minus 1 to 9 by 5 x plus 5 plus 16 upon x minus 5 dx plus x square by 2, where 9 by 5 is the maximum. So this will be equals to 28 upon 25 plus 14 plus 16 log 8 upon 15 plus 72 upon 85. So it will be equals to 18 plus 16 log 8 upon 15. It is clear that here alpha 1 is equal to 18 and alpha 2 is equal to 16. So we have to find the sum. So alpha 1 plus alpha 2 will be equal to 18 plus 16, which is equal to 34. Hence, we can say that alpha 1 plus alpha 2 is equal to 34. So the correct answer is 34. I hope this question is clear to you. Next question is, if two tangents drawn from a point alpha comma beta lying on the ellipse 25 alpha square plus 4 beta square is equal to 1. We can also replace it by alpha and beta since it is lying on the ellipse. To the parabola y square is equal to 4x are such that the slope of one tangent is 4 times the other, then the value of 10 alpha plus 5 whole square plus 16 beta square plus 50 whole square equals. So here, since alpha and beta lies on the given ellipse, so the equation changes to 25 alpha square plus 4 beta square is equal to 1. Let this be equation number 1. We know that tangent to the parabola y is equal to mx plus 1 upon m passes through alpha comma beta. So we can say that alpha m square minus beta m plus 1 is equal to 0 has roots m1 and 4m1. Therefore, the sum of roots will be m1 plus 4m1 is equal to beta upon a, and the product of roots will be m1 into 4m1 is equal to 1 upon alpha. Now it gives that 4 beta square is equal to 25 alpha. Let this be equation number 2. You can see that we have two equations. So from equation 1 and 2, we can write 25 alpha square plus alpha is equal to 1. Let this be equation number 3. Now tan alpha plus 5 whole square plus 16 beta square plus 50 whole square will be equals to 25 into 2 alpha plus 1 whole square plus 2500 into 2 alpha plus 1 whole square. So this will be equals to 2525 into 4 alpha square plus 4 alpha plus 1 from equation number 3. So this will be equals to 2525 into 4 upon 25 plus 1. On further calculating it, this will be equals to 2929. Hence, we can say that the correct answer for this question is 2929. I hope this question is clear to you. It was a very, very important question. Next question is, let S be the region bounded by the curves. We have two curves, which is y is equal to x cube and y square is equal to x. The curve y is equal to 2 into mod of x. Again, third curve is y is equal to 2 into mod of x divides S into two regions of areas R1 and R2. If maximum of R1 and R2 is equal to R2, then R2 upon R1 is equal to. It is very important to understand the diagram first. Consider this figure. Let this be the line for y is equal to x cube, and let this be the curve or the parabola which is for y square is equal to x, and let this be another curve which passes through the center somehow this way. So here this point will be 1 and this intersecting point of this 3 will be 1 by 4. I hope the diagram is clear to you. You can clearly see that curve 1 and curve 2 intersect at 1, 1 and curve 2 and curve 3 intersect at 1 by 4 and 1 by 2. So it is clear that R1 will be equals to integral of 0 to 1 by 4 under root of x minus 2x dx. So it will be equals to 2 by 3 into 1 by 8 minus 1 by 16, which will be equals to 1 by 48. Also, R1 plus R2 will be equals to integral of 0 to 1 root x minus x cube dx, which is equal to 2 by 3 minus 1 by 4. So it will be equals to 5 by 12. So R1 plus R2 upon R1 will be equals to 5 by 12 divided by 1 by 48. So it gives 1 plus R2 upon R1 will be equals to 20. So we can say that R2 upon R1 will be equals to 20 minus 1, which is equal to 19. Therefore, the correct answer for this question is 19. Next question is, if the shortest distance between the lines R vector is equals to minus I plus 3k plus lambda I minus aj, and R vector is equal to minus j plus 2k plus mu into I minus j plus k is root 2 by 3, then the integral value of A is equal to. It is clear that B1 vector cross product B2 vector will be equals to I, j, k, 1 minus A0, 1 minus 1, 1. So this will be equals to minus of AI minus j plus A minus 1 into k cap. So a1 vector minus a2 vector will be equals to minus I plus j plus k. Now, shortest distance will be equal to mod of a1 vector minus a2 vector dot product b1 vector cross product b2 vector whole divided by mod of b1 vector cross product b2 vector. So this will be equals to under root of 2 by 3 is equal to 2 into a minus 1 divided by under root of a square plus 1 plus a minus 1 whole square. So we can say that 6 into a square minus 2a plus 1 will be equal to 2a square minus 2a plus 2. So a minus 2 into 2a minus 1 will be equal to 0. It implies that a will be equals to 2 because we know that a belongs to z. Hence we can say that the integral value of a is 2. So the correct answer for this question is 2. I hope all these questions are clear to you and concept related to each and every question is also clear to you. Keep learning more and keep scoring high.